In this video, I'm going to show you how to use the distance formula to find lengths of a line segment given two coordinate points. So let's review how to find the line segment, the length of this line segment here. Remember, we create a right triangle, and to find the length of this line, we use Pythagorean theorem. So this side right here, the vertical line is 1, 2, 3, 4, 5, 6, and the horizontal line is 5. 1, 2, 3, 4, 5. So to get the length of this black line segment, you do 6 squared plus 5 squared. That is equal to 61, and then you take the square root of 61, and you get approximately 7.8 when you round to 1 decimal place to the tenths place. Okay, so that's how you would do it the old way. I'm going to also show you how to use the distance formula. This is the distance formula, the square root of x2 minus x1 squared plus y2 minus y1 squared. And I'm going to show you how we would get the same answer using the distance formula. So, first thing I'm going to do is I'm going to write out the points, the endpoints of this line segment. So this point right here is 1, 4. And this point right here is -4, -2. And then what I'm going to do is I'm going to label each coordinate, the coordinates of my points. I'm going to label this x1, y1, and I'm going to label this x2, y2. So that way when I go to substitute into my formula, it's a lot easier. I've already defined my variables, so it's easier to substitute into the formula. So now I'm going to solve this. So I'm going to put the square root. My x2 was -4, then minus my x1, which is 1, squared, plus my y2, which is -2, minus y1, which is 4, squared. And then I'm going to do some math. -4 minus 1 is -5. I'm going to keep that in parentheses, then squared, plus -2 minus 4, which is -6, and I'm going to keep that in parentheses as well, squared. So -5 squared is -5 times -5, that's going to be 25, plus -6 squared, which is 36. 25 plus 36 is 61. Do the square root of 61, and you're going to get 7.8. Obviously, it's a lot easier to use the Pythagorean theorem on this example, but sometimes you're not going to be given a coordinate plane, and you're not going to be able to plot it. Sometimes you might be given decimal points or fractions, and so it's a little bit harder to use Pythagorean theorem when you don't have exact points and you're given decimals or fractions. And so that is where the distance formula is going to come into handy. So now I'm going to do a couple more examples for you using coordinate points. So once again, that's my distance formula. And to start out, I'm going to label my x1, y1, x2, y2. I'm just going to say that's x1, y1, x2, y2. And then I'm just going to substitute into my formula. So -7 minus 8 squared plus y2, which is 5 minus -5 squared. So -7 minus 8 is -15 squared. 5 minus a -5, that's a +10. -15 squared is 225 plus 100. So the square root of 325, put that in the calculator, round to 1 decimal place, I get 18.0. Alright, let's do one more example. I'm going to label this x1, y1, x2, y2, substitute into my formula. 6 minus 6 squared plus negative 6 minus negative 3 squared. 6 minus 6 is 0, 0 squared, plus negative 6 minus a negative 3 is going to be a negative 3 squared. Negative 3 squared is 9, so the square root of 9 is going to equal 3. So that is going to be the distance between the 2 points. Like I said, I showed you some examples where it worked out pretty nicely, but sometimes these coordinate points right here could be decimals like 6.1, comma 2.65 and things like that, and you want to know how to use the distance formula so that way you can find the distance between the points if it's not so nice all the time. So that is an example of some coordinate points that you could use in the future for the distance formula.